Welcome to the first video for either the Algebra 1 or Algebra 2 tracks. This is also a great topic for anyone who is getting back into math to take a look at because it's relevant in terms of what are some of the basic rules of numbers. So this is Properties of Real Numbers Part 1, where we're going to talk about the Commutative Property, the Associative Property, and the Distributive Property. In a future video, we'll talk about a few of the other rules, but that is the focus for this particular episode.
Okay, so let's go ahead and get into this first topic of properties of real numbers. So we're going to go over three properties in this episode. The first one is going to be the commutative property. And if there is a tagline or a hashtag that goes with the commutative property, it is that order doesn't matter. Okay, so let's think about that a little bit and ask ourselves, what are some examples of when the order or sequence of things doesn't really matter? Okay, it doesn't have to be a math or numbers thing. It can be anything. If you think of something, go ahead and put it down in the comments. I'd love to hear what you guys come up with. But from this end, a couple of thoughts that I had about this question are things like sometimes some parts of a recipe could fall under this category. Like, for example, if you're going to be making a recipe for a baked good or of some sort, usually the dry ingredients, it doesn't really matter whether you put the sugar in first or the salt in first or the baking powder in first for a cake or the baking soda in first. Those dry ingredients can often go in pretty much in any order. Similarly, things like putting on your socks. It doesn't really matter whether you put on your right sock first or your left sock first. At the end of the day, whichever one you do first, you're still going to end up with your socks on. So those are some examples of where you can do things and you'll get the same result even if you do things in a different order. Okay? So let's talk about this whole commutative property and what it really means from a math perspective. Let's start with a definition of commutative. This comes from the Merriam-Webster Online Dictionary. And so to commute things means to exchange their positions. So if you think of maybe one of the most common uses of the word commute, okay, that usually corresponds to our ideas about going to and from the workplace, right? So the commute is not the actual act of traveling. The commute is exchanging your position in space. That at one point, say in the morning, you were at your house, and that when you commuted, okay, when you exchanged your position, the new position was at work or at school. Okay, so that is how that word is supposed to mean. Now, mathematically, what that means is that you can move terms, add-ins, and factors around. And then, so in doing so, you make them switch places with other terms, add-ins, or factors. Because when it comes to addition and multiplication, order doesn't matter. Now, I have two caveats to that statement. Is that first, it's only addition within addition and multiplication within multiplication. If you have a mixed expression that has addition and multiplication, then order of operations is going to take precedent, so it won't really matter. But if you have several things added together or multiplied together, you can apply this commutative property. You'll notice I also have an asterisk on that second bullet point, and that is because while we generally say that this only applies to addition and multiplication, we're going to see that with a little math magic, you can make it work for subtraction and division as well. And then finally, why do we bother learning this? What is the point of even going over this idea of properties? And simply, it's that it can help make solving equations or simplifying expressions a little bit easier, because sometimes a change in perspective makes all the difference. That you're like, oh, I didn't look at that problem that way, but now that's a much easier problem for me to solve, either in my head or even on a piece of paper. But sometimes we get really locked into the process of solving a problem, and then we think we have to work it left to right, and that's not necessarily always the case. So the commutative property is really important because it gives us flexibility in solving problems. So let's see what this then looks like algebraically if we use some variables. And so again, what it is saying is that order doesn't matter. So this first example at the top is addition, and I can say that A plus B is the same as B plus A. And remember, equals could have lots of different common language translations, but especially when we're talking about properties, thinking of it as a symbol for the phrase is the same as really helps put into perspective what it truly means to be equal. Okay, so for a numbers example, we have 2 plus 3, which is the same as 3 plus 2, because both 2 plus 3 equals 5 and 3 plus 2 equals 5. If you remember back to when you were first learning how to do addition, it doesn't matter if you started with 2 apples and got 3 from your friend, you had 5, or if you had 3 and got 2 from your friend, you still end up with 5. Okay, so with addition, clearly order doesn't matter. Then in multiplication, and I have several different ways of writing that multiplication down below in this second example, but basically if you have A times B, that is the same as B times A. So in this example with numbers, we have 4 times 5 is the same as 5 times 4. Again, you could have a cluster of 4 5 times, or you could have a cluster of 5 4 times. Either way, both sides end up being 20. So multiplication is also commutative. Now, remember I said a little bit of math magic will let us get the same property applying to subtraction and division. So if we talk about subtraction, we just need to transform it into addition, and that's so easy to do. So remember, anytime you see a minus sign, you can turn that subtraction sign into an addition sign as long as you make whatever comes after it negative. Okay, so let's look at this example. We have 2 minus 3, which we know does not equal 3 minus 2. Okay, because 2 minus 3 is going to be negative 1, and 3 minus 2 is positive 1. So we can't just flip-flop numbers and come out with the same thing. That's not how this works. But if I transform those subtraction expressions, into addition expressions, now I can. So let's say I'm going to make that subtraction sign become a plus sign, and instead of positive 3, it becomes a negative 3. Okay? So now I have the number 2 plus the number negative 3, and that is equal to the number negative 3 plus 2. You'll end up with negative 1 on both sides. So that is one way that you can make subtraction adhere to the commutative property. Next, let's talk about how you can use division by transforming it or rewriting it as a multiplication problem. This is going to be less common, but certainly in higher levels of algebra, it might become in really handy. So let's consider the two numbers of 4 and 8. All right, so if we have 4 divided by 8, we can definitely say that that is not the same as 8 divided by 4, right? Because if I have 4 things and I need to divide them amongst 8 people, I'm going to cut them all in half so that everyone gets 1/2. Okay, that's the only way to do that. Okay. On the other hand, if I have 8 things and I need to divide them amongst 4 people, everybody's going to get 2. Okay, so in one situation, everyone gets half, and in another situation, everybody gets 2. All right. But it's important to remember that you can rewrite the left side of that expression, that equation, to become a multiplication problem. So 4 divided by 8, okay? We can rewrite that as 4 over 8, okay? Now that we're moving out of arithmetic and pre-algebra, okay, now that we're into algebra, we're not going to really say 4 eighths anymore for the most part, okay? We're going to say 4 over 8. You might even say 4 divided by 8, because remember, a fraction bar is just another type of division symbol, okay? So if I have 4 over 8, okay, remember that 4 always has a ghost 1 next to it. There's next to every number, every term, everything, there is a ghost 1 hanging out next to it, okay? And so I can pull out the 4, okay, and make it be its own thing, and I'd still have 1/8 left on its own. And so I can rewrite 4 over 8 as 4 times 1 over 8. Now I have a multiplication with two numbers, and I can flip-flop those all I want, and I will get the same number regardless. So that is how I can do a little math magic to make subtraction and division adhere to the commutative property. All right, so that's the commutative property. Let's move on to the associative property. And for a hashtag or a motto, if you will, however you want to phrase that, it's going to be that grouping doesn't matter. Okay, and so you see here on this title slide, we've got brackets, curly brackets, square brackets, and parentheses. And so with the grouping doesn't matter idea, it's just really important that you understand that even without changing the order of any of the terms, okay, I can change the brackets, like what the brackets are bracketing, or the parentheses are parenthesing, without changing the outcome. All right, so this is a little bit trickier, I think, to think of real life examples, but there are plenty of them. Okay, so again, let's give it a little bit of thought. What are some examples of when grouping doesn't really matter, and you still have the same result no matter what? Okay, so give it some thought. Put your thoughts down in the comments. Again, I'd love to see what you guys are coming up with. Okay. One idea that I had about this is when you're making a bologna sandwich. All right. So for me, making a bologna sandwich has 4 components. There is a piece of bread, a piece of bologna, a little happy face squirt of mustard, and another piece of bread. And yes, the mustard has to be in a happy face. That's just how this works. Okay, so I think a lot of people will start with, let me put the bologna on the first piece of bread first. And so if you think of that action as being in parentheses, that the first bread and bologna come first, and then the mustard, and then the second piece of bread. Okay, think of that almost as an equation. All right. But think about it. If I do the mustard on the second piece of, like I put those in parentheses, the mustard and the second piece of bread, and I do those first, okay, well, that's still going to give me a bologna sandwich in the end. the grouping of things didn't really matter. Or what if I put parentheses around the bologna and the mustard themselves, and I put the happy face directly onto the bologna first, and then I put the bread on either side of that bologna. So again, it doesn't matter how I group things, okay? I'm still going to end up with the same bologna sandwich at the end of the day, all right? So, like we did before, let's talk about the associative property in terms of what does the word associate really mean. And so Merriam-Webster has a lot of different definitions for a lot of words. So I wanted to highlight that the one we're going to use is this one about joining or connecting things together or to combine things. Okay. So again, mathematically, that means that when you have 3 or more terms, you can switch the parentheses or other grouping symbols like brackets, and then the result will still be the same. Even if you don't change the order, leave the order exactly the way it is, but changing the grouping symbols will still result in the same value. Again, we have a caveat, important note here that this applies only to addition and multiplication. And then the reason why you might employ this is that sometimes a grouping is easier to do quickly in your head than others. So for example, you might be really good at multiplying things by 10, but you're not so good at multiplying things by 7, okay? So if you have the problem 6 times 7 times 10, okay, where 6 times 7 is in parentheses, okay, maybe your 7s is not your strong multiplication table, and that's totally okay. But 7 times 10, even though it's a 7, you know your 10s. 10s are easy. Just add a 0, right? So you could fundamentally move those parentheses from being around the 6 and the 7 to being around the 7 and the 10, because now you can easily do that problem, the 7 times 10 to be 70, and now you're just dealing with 6 times 70. And that might be an easier way to approach that problem, okay? All right, so algebraically, what this looks like is that, like I said, you just pick up the parentheses and put them somewhere else. Do not change the order of the terms. So this first example, we have 2 plus 3 in parentheses plus 4 on the left side. And on the right side, we have 2 plus the quantity 3 plus 4. So when we simplify each side independently, okay, the left side becomes 5 plus 4, and the right side becomes 2 plus 7. These are different expressions, but 5 plus 4 is 9, and 2 plus 7 is 9, so you get the same value. The same thing applies to the second example on this slide. So the quantity 5 times 6 times 7 is the same as 5 times the quantity 6 times 7, okay? So the left side would be 30 times 7, and the right side would be 5 times 42. And then 30 times 7 is 210. And I will leave it to you to either trust me or get out a calculator and check it for yourself. But 5 times 42 is also 210. So they are equal. Now, what about subtraction and division? Can I do math magic again? Well, it turns out you don't need to for subtraction, okay? Because of the way integer arithmetic works, you're going to get the same answer regardless. So 8 plus 9 quantity minus 10 gives you 17 minus 10. And then the right side of that one is that 8 plus the quantity 9 minus 10 is going to be 8 plus negative 1. Okay? And so 17 minus 10 is 7, and 8 plus negative 1 is 7. So the nature of integer arithmetic allows us to be able to apply the associative property without actually having to do any magical math transformations. You can do it with division, but I wouldn't. It's not recommended because basically to do that, you're going to create another grouping instead of eliminating one, and it'll actually make the problem more complex or more complicated. So by and large, don't do it with division. And if you see subtraction, you can definitely still use it. With the caveat that if your first term is followed by the subtraction sign, you may run into other problems. So see my short video on why I have abandoned subtraction for more information about that one. All right, so we've learned about the associative property and the commutative property. They are actually combinable. You can apply both of those properties in different steps of a problem in order to simplify it or to solve it. So it's not like pick one property for the entire problem. No, you're going to use as many properties as you can in a problem to get to where you need to go. So it's always important to remember you got both of those things as tools for yourself. Okay. Let's talk about one final option, and that is called the distributive property. And for this one, I would say that you're going to do this because sometimes 2 multiplication problems is easier than 1. Now, a word of caution. When we talk about the distributive property, okay, this is not about distributing equal amounts to things, okay? It's not a division, okay? It's not saying I want to make sure everybody has 3 apples to every group or something. It's not that kind of distribution. It's about coverage, okay? And I'm going to explain more about that as we get into looking at what this looks like algebraically. But first, let's do what we did before, and let's look at the dictionary to see what the word distribute actually means. So to distribute in this second definition is to spread out so as to cover something or to scatter it. Okay, so we're going to have coverage. All right. So what does that mean in terms of math? Well, it means that you can spread a multiplication operation across 2 addends of a sum or difference. Okay. So instead of having to do the parentheses first and then having a potentially difficult multiplication problem to work with, you can do 2 smaller multiplication problems and then add those together, which might be easier, okay? And then just kind of as a heads up, we also use the distributive property heavily, okay, in algebraic problem solving in order to isolate variables that are otherwise tied to other factors or terms because they are in parentheses. So often when we need to get rid of parentheses when solving an equation, we will employ the distributive property to do that. Okay, so it's a very handy, it's a bread and butter kind of tool that you're going to use pretty much now until the end of your math life. So let's look at how this works mechanically. So this first example, you have A times the quantity B plus C, okay? So you can rewrite that. You can do, what we do is we say we are distributing the A across B and C. And then remember, this is going to be coverage, not a division, it's a coverage. So we're going to have A times B, and then we're going to have A times C, and we're going to then add those 2 things together. So when we put in numbers, all right, that means let's say we had 2 times the quantity 3 plus 4. Okay, now using the distributive property, we can rewrite that as 2 times 3 plus 2 times 4. Okay, so that 2 is being multiplied by both of those numbers separately, and then we're going to add those two products together. All right. So if we work both sides independently, 2 times the quantity 3 plus 4 is going to be 2 times 7. And then for the right side, we have 2 times 3, which is 6, plus 2 times 4, which is 8. And so either way you do it, you'll get to 14. Now, in this particular case, you might find that with these smaller numbers, it doesn't make that big of a difference. You can do that kind of math in your head without too much problem. But think about what happens if you have much larger numbers, okay? So let's say you have 12 times 12 plus 10, okay? If we were to do that the left-hand side of the way, it would be 12 times 22. Not everybody does that in their head super easily, okay? But if you had 12 times 12 plus 12 times 10, that might be a lot easier depending on how good of your times tables with 12 are, okay? So that's an example of where you might use distributive property to make an easier set of mental math for you to work. Also remember, we talked a little bit earlier about how there is always a ghost one next to any term or variable or number, and that also applies to the outside of parentheses. There is always a ghost one. And in the case that you have 5 minus and then something in parentheses, there's technically a negative one hanging out on the outside of that parentheses. So if we have 5 minus the quantity, 6 plus 7, okay, think of that as actually being 5 minus negative 1 times the quantity 6 plus 7. So then when we distribute the negative 1, okay, we're going to have 5 plus negative 1 times 6 plus negative 1 times 7. And that is going to leave us with 5 minus 13 on the left, and then 5 plus negative 6 plus negative 7, which also ultimately reduces to 5 plus negative 13, which is the same thing as 5 minus 13. All right, so that is 2 examples of using the distributive property. Again, you're probably wondering, what about division? So you can transform division into multiplication just like we did with the commutative property, because if you think about it, in this particular example, we've got 8 plus 9 in parentheses. Think of it as its own number. So just like before, when we pulled out the 1/4, okay, we pulled out the 1/8, we can pull out 1/10 and then just have 8 plus 9 hanging out there on its own, okay? So if we were just to do 8 plus 9 all over 10, okay, that's just 17 over 10. That's this right here, okay? But if we distribute 1/10 over 8 and over 9, okay, 1/10 times 8 is 8/10, and 1/10 times 9 is 9/10. And then when you go to simplify that using your fraction arithmetic rules, you're again going to get 17 over 10, okay? So it's going to be the same regardless. It's just a different way, again, remembering that you can always have a fraction be a coefficient to either a variable or a term or a set of parentheses. That's totally allowed, okay? Just keep in mind that this is not always an efficient method to solve the problem. So don't get super locked in on, I have to do it this way, because that isn't necessarily going to be true, and there may be a simpler way to approach that particular problem.
All right, and that's all we've got for this particular episode. Those are the first three of the properties of real numbers that we're going to go over as part of our introduction for Algebra 1. Again, this would have been a great review for you if you are getting ready for Algebra 2 or you're getting ready for geometry. Please leave your questions in the comments. Let me know if you thought of any other real-world examples where order doesn't matter or groupings don't matter. Love to hear your thoughts on that. And if this is a channel and teaching style that is working for you, please subscribe. And we'll see you next time when we cover some more properties of real numbers. See you next time.